Hello everyone, myself Pratham Arna and I am doing masters in IIT Kharagpur and I am from Odisha. Today I am going to teach electrochemistry. This is important topics in terms of JEE Mains as well as JEE Advanced. And if you read carefully the electrochemistry, it is consist of two words, electro and then chemistry. From electro we can conclude the electricity, and from chemistry we can conclude the chemical. So basically in electrochemistry we are mainly deal with the interconversion between the electrical energy and the chemical energy and how they are correlated. For the interconversion of these two energy we need a device, and this device name is known as electrochemical cell. This electrochemical cell is destined for the conversion of electricity to chemical, conversion of electrical energy to the chemical energy. Further, the electrochemical cell is further divided into two categories: galvanic cell, and it is also known as voltaic cell, and the another cell is electrolytic cell. So what is the major difference between the galvanic cell and electrolytic cell? Basically, in galvanic cell or a voltaic cell, the chemical energy, basically the chemical energy converted into electrical energy, and in electrolytic cell it is opposite to that of galvanic cell. In this, the electrical energy got converted into chemical energy. So let us differentiate between these two cells. What is galvanic or voltaic cell and what is electrolytic cells? And this cell is spontaneous, and basically this cell is non-spontaneous. That means for the working of the cell, we put an extra energy to working this cell. But in this case, the cell is already working. For this, we do not have to give an extra energy for the working of this cell. Or we can say the change in this energy is negative for this cell, and for this cell, the change in this energy is positive. Right? Because we have to give the electrical energy for the working of the cell. Galvanic cell. And if we give the sign convention for this, in both the cell, anode and cathode, in anode oxidation takes place. Here in this cell also oxidation takes place. Or in this cell, in cathode, reduction takes place. Also in this cell, reduction takes place. But the difference is in this cell, we take anode as negative and cathode as positive. But in this cell, we take anode as positive and cathode as negative. Then then the galvanic cell, there is a two kind of galvanic cell: single component galvanic cell and the double compartment galvanic cell. It is further divided into two classes: single component galvanic cell and double component galvanic cell. So what the difference between single component and double component? Basically in single component galvanic cell, we did the redox reaction in a single container. All the oxidation all the oxidation of cell as well as the reduction of cell occurs in a single container. For example, let's say a container contains copper sulfate as an electrolyte, and we dip a zinc electrode. So, and we know that the zinc is more electropositive metal than the copper. It is more, it is readily oxidized to convert zinc as 2 and 2 electron. And these 2 electron was consumed by the copper plus 2. So both the redox reaction takes place in a single component. But in double component galvanic cell, it is consists of 2 components, and 2 components have a 2 metallic electrode and deep in their respective electrolytic solution. Let's say it is a zinc electrode and it is a copper electrode. It is deep in their electrolytic solution. Let's say zinc is lead SO4 and copper is deep with the copper electrode is deep with the copper sulfate, and these two are connected externally through an wire, and internally these are connected through one salt bridge. So as in previous case, as we say that zinc is more electropositive metal than the copper, it is easily get to oxidize. So here in this cell the oxidation half cell reaction is these 2 electrons goes through an external wire, and here the copper plus 2 present in the solution consume these 2 electrodes to form copper, and internally these circuits were completed by the salt bridge. It has a major function in this role. If the salt bridge was not present, then this cell will not working for some time. If salt bridge is not present, this cell is working, but after some time it will stop. But if we put in salt bridge, it is working through the through after some reaction. Then, so let us discuss about the salt bridge and what is the major application of a salt bridge in this reaction, in this cell. Salt bridge. So salt bridge has three major applications, three major roles in a double component cell. What are these three? So first, to maintain electroutility of the cell. It maintain the electroutility of the cell. As the cell working, the concentration of the positive ion, the concentration of the electron is increases throughout the cell. That's why the cell stop working. So salt bridge is used to maintain the electroneutrality of the cell. And the second one, it fulfills the and it internal circuit of the cell, and the third and the major role in this cell was to minimize the liquid junction potential. These are the three major role of salt base in this double component cell. And in many competitive exams, this most of the question was coming from the salt base. So one of the most questions that is appearing in many competitive exams, that the salt base in galvanic cell only allows the flow of ions, not electron. It is important that the salt base only allows the flow of electron in a double component cell, not electron. There. Next, we discuss about the electrode potential and what is an electrode potential and various electrode potential we have to discuss further. Next topic, electrode potential. So, what is an electrode potential? Let's consider an example. Let a container contain some electrolytic solution. Let's say copper sulfate, and zinc metal is dipped into this solution. Or, or more generally, let's say metal. This is the electrolytic solution. As the metal is converted into metal N plus, and due to this, the solution get positive as the metal is readily converted into its cationic form, and the electron present in this electrode, and it appears some negative. So the electrolytic solution is positive and the electrode is negative. So there is a create of potential difference. So there is a create a potential difference between the electrolytic solution and the electrode. This potential difference is known as electrode potential. That where again. So this is an electrode potential. Then this electrode potential is further divided into oxidation potential and again reduction potential. So the oxidation potential gives information about the tendency of a metal to oxidize. And by simple, in the reduction potential also gives us information about the tendency of a metal to reduce. More the oxidation potential, that means the oxidation capability of the metal is higher. More the reduction potential of a metal, that means to gain electron or to gain the electron, the tendency of a gain electron is higher. The reduction potential is high for the metal. Also, we can say that from this information we can say which is a more oxidizing agent, which is a more reducing agent. That the information we get from the this information. And again, and we majorly next topic, how you measure measurement of standard measurement of electrode potential. Measurement of electrode potential for any kind of, let's say I am saying that I am tall from this side. When I am tell that I am short from the this side. This is a reference relative term. So in that way the potential standard potential also has relative term. We have to make a reference for this, and we take reference as hydrogen electrode. This is an example of an hydrogen electrode. This electrode dip in an HCl solution and continuous gas of hydrogen passed into this tube and an platinum wire is used. And we connect this cell in another electrode. Let's say this is anodic compartment and it is, let's say it is cathodic compartment, and we say that E cell is equal to E naught of cathode minus E naught of anode. This implies, so as we know that E S plus S2 E S2 S plus is equal to 0. So standard hydrogen electrode, the cell potential is 0. So E cathode tends to 0. So E cell is equal to minus E naught of anode. So from this we can calculate the electrode potential of any cell. So thank you. So in summary, in today's lecture we study the basic of electrochemistry, what is an electrochemistry, and how they are separated, and different types of cell, and we mostly study the galvanic cell, how the chemical energy get converted into electrical energy, and we study also for the what is the electrode potential and how to measure electrode potential.